Question 1. This is a binomial expansion in the normal sense, except we only want the first 4 terms in this expansion, which would otherwise have 8 terms if you did the whole thing, because it's power 7. So you could kick off, if you wanted to, by writing out Pascal's triangle all the way up to row 7. But that might take you, thick end of a minute of your exam time. So if you didn't want to do that, you could just simply generate, using your calculator, the 4 binomial coefficients that you need: 7c0, 7c1, 7c2 and 7c3. The calculator will just give those, if you type them in, as 1, 7, 21 and 35. So then the next step is just to think about what's going to happen with each, what I call a row, each term. So we have the binomial coefficient, the first term to a power and the second term to a power. And those powers always have to add up to 7. And we start off by raising the first one to the power 7 and the second one to the power 0. Of course, the power 0 is just going to give you 1. And then with the next term, if we continue, the 1 is going to be raised. The first term is going to be raised to the power 6 and the second term to the power 1. Again, the powers adding up to 7 each time. Carry on that pattern until you've generated all 4 complete terms. And then all we need to do then is calculate them. They're all products. So the first term is generated by doing everything in the top row times together. So you've got 1 times 1 to the power 7 times 1, because 4x to the power 0 is just 1. So the first term is just 1. The second term, 28x, because we've got 7. Again, the 1s are not really contributing anything, but we've got 7 times 4 there. The third term, be careful, you've got 21 times 4 times 4, because that's 4 squared, isn't it? 4x times 4x gives you 16x squared. So 21 times 16 gives you 336. Of course, you get the x squared. And lastly, if you do 35 times 4 cubed, 35 times 64, you get 2,240, and that gives you the number of x cubed. And that's it. You're done, except you simply need to write out the sum of the terms in the way that they expect you to do. That's the expansion. So there we have it. There's our answer. Let's just write that off and consider part 2. Now, you first have to note that we need to use the result from part 1 in part 2. And we don't actually need the whole thing. Let's just write that out to begin with. We've got 3 plus ax times our result from the expansion of in question 1. But you'll see in a second that we don't actually need the whole thing. I'm just going to put a ... there, because there's no point in considering the x cubed in higher terms, because we're only interested in how to create the x squared term. So if we were to expand that set of double brackets there, what's going to create an x squared term? Well, 3 times 336 x squared is going to create some x squared. And it gives you that many x squared. And then ax times 28x is going to give you some more x squared. And that's it. There's no other way of creating x squared. So that's all we're interested in. And together, those 2 terms must add up to the number in the question, which is 1001. And solve that for a, and there's your answer.